Hi, in the last video I discussed about two tests. One was sign test, which was used for the matched pair or one sample t-test, equivalent to that. And then the another test I discussed was Mann-Whitney U-test. That was similar to the two sample t-test with independent samples, okay, unmatched pair. That's what we discussed. So the next a non-parametric test I'm going to talk is Wilcoxon test. So there are two types of this test. One is for the matched pair and other is for the independent pair. Okay, so one is equivalent, similar to the sign test. The other is similar to the Mann-Whitney U test. Okay. So, and I will also talk about how do we use R to do these tests. And again, so the Wilcoxon test for the matched pair or the Wilcoxon test for independent pair, there are two types, and the independent pair or independent sample Wilcoxon test is similar to the Mann-Whitney test. Actually, when we use R, we use the Wilcoxon test for the Mann-Whitney test too. Okay, so they are similar to each other. Okay, so let us talk about this. As a sign test, Wilcoxon signed rank, this is the signed rank test, can be used to test a claim that a single population of individual values has a median equal to some claimed value, and the claim and population of matched pair have difference with medians equal to 0. So we will be testing whether the median equals to certain number in one sample test, or the median of two populations is equal for the two sample test. Okay, for a single population we create matched pairs by pairing each sample value with the claimed median. So the same procedure can be used for both of the cases. The assumptions are the sample must be random and the population of the difference is approximately symmetric. Okay, so from on the left side and the right side they must follow the similar distribution. Let us talk about the steps for the Wilcoxon signed rank test. So we need to write H0 and H1. Okay, so H0 is, in case of the one sample test, the median equals to certain number versus median less than or greater than or not equals to, right? If the two sample test, then you say that the median of the two samples are equal, or the difference of the median is equals to 0, right? And from the data, find the difference of the matched pair. So we need to first find out the difference of the matched pair, then rank the absolute value of the difference. Okay, then assign negative sign to the ranks with negative differences. Discard any pair with 0 difference. You see that? So I'm taking this example. So this example is not given in the slide, but what I'm trying to do here is I'm trying to do the Wilcoxon signed rank test to these two data sets. See, matched pair, because they have the same sample size, and then suppose that those data are taken from the same subject, so they are the dependent sample. So first of all, find out the difference, x minus y, right? And then that is g. So if you run this one, you get y, and then g is x minus y. That is the difference. This is the difference, right? So what you do is you rank the absolute value of this difference. So let us rank the absolute value. This is what you get. So first of all, ignore the sign and rank the smallest one as 1, and the second smallest 2, and then this will be 3, and then this will be 4, this will be 5, right? What you do next is you find out t plus and t minus. So what is a t plus? T plus is the sum of the rank of the positive values. So what is the rank of 6? Is 2 plus 5 plus 4, right? That is 11. That's why the t plus is 11. So to find out the t plus, you add the rank of the positive values, and then to find out the t minus, you add the rank of the negative values. So rank of negative 2 is 1 plus rank of negative 10 is 3. So 1 plus 3 is 4. That's what you get. T minus is 4. Okay, so I was doing that. So what will be the test value? So the test value is the smaller of t plus and t minus. So here in our case we get 4. That is the test value. Okay, so the test statistic is the smaller of those absolute value of t plus and t minus. Now, with given alpha and number of non-zero difference, okay, find the critical values. from table uploaded in day 12. So actually I have uploaded it here. Okay, so it is two-tailed test. What is the sample size? 5. The sample size is basically the size of the length of the differences, right? Or you can say how many are there. That's the sample size. So sample size is 5, right? And two-tailed test, this is alpha 2, and then this is 5 is the 5%, right? So that is 0. Oh, sorry, this is 0. That is 0, not the other one. Okay. So what do you get? You get the critical value is 0. So critical value 0. So what does it say? So we found out the critical value, and then so from the table, and then if the test value is less than the critical value, we reject. Is our test value less than the critical value? No, because test value is 4, critical value is 0. So test value is bigger than the critical value. You see that? So we do not reject the null hypothesis, meaning that they have the same median. Okay, you can say that these two have the population of these two samples have the similar median. Okay, that's what we can say. Okay, so we can do this whole thing directly from R. How do you do that? You do Wilcox.test, and then inside the parenthesis you can write x comma y, and then paired equals to true because it is a paired test, right? And alternative is two-sided, right? So what do you see here? Your p-value is 0.4375. Since the p-value is greater than alpha, so you can write p is greater than alpha. So reject the null hypothesis. That's what we can say from here. Okay, guys. So this is how we do the Wilcoxon rank sign test using R and manually. Okay, let us do another more example there. So look at this. So none of the values here are repeated, right? None of the values here are repeated. So if the values are repeated, then we will have a tied ranks there. In that case, when we do by hand, you do exactly the same steps, but when you do by R, then we need to do a little bit different thing here, because otherwise it will show warning sign. Okay, so we need to install a package called exact rank tests. Okay, first you need to run this, and then after you run this, you need to do the library. Okay, I have ran that already. I installed that package already, and then so what I am going to do is I will be using the Wilcox.exact because of the tied ranks, because of the tied values. Okay, you see that? Needs for the tied ranks. That's what you will be needing. Okay, so this is that example. So so this is the following data represents the length of hind leg and foreleg for 10 randomly selected deers. So for alpha equals 0.05, test the claim that the length of the hind leg and foreleg are equal. That's what you want to test. Okay, so hind leg data is given. See, you see that they are repeated values there. Okay, and also see, there is another repeated here. Where is that? That will be 143 is repeated on the second one, right? So the values are repeated there. So in that case, so when you do by hand, it is exactly the same steps. So H0 is deer hind leg length is same as the foreleg length, and H1 is the deer hind leg length is different from the foreleg length. So so what is happening there is, since those hind leg and the foreleg length are taken from the same deer, so it is dependent sample. It is the pair test, right? So first find the difference of the pair. So what I'm doing here is I am finding the difference. So let me run x and y first. So x is that, y is that, and then I'm finding the difference. So that is the difference there. So difference of x and y. Now you need to rank the, so find out the absolute value and then rank the absolute value. Okay. So we got m equals to absolute value of g, and then rank that. Okay. So what you need to do is you need to add the rank of the positive value. So we need to add the rank of this. 4.5 plus 4.5 is 9, plus 7 is 16, plus 7 is 23. Okay, plus 9.5 plus, because we need to add the rank of these two numbers separately because they are negative and we denote by t minus, right? That will be 3 plus 1, and all other are positive values. So we need to add the rank of all other values. Okay, if you do that, you will get t plus equals to 51 and t minus is 4. So the test value is the smaller of t plus and t minus. We got 4. Now to find out the critical value, what is the n? N is total values of n is 10, right? Because the 10 is the total number of pairs. So what you need to do is you need to go to the n equals to 10. Okay guys, so this is n equals to 10, right? So let us write down, let me underline that, n equals to 10, alpha equals 0.05, and then two-tailed test. So what is this? This is basically the critical value. You see that? Let us go up. So the critical value is 8. Okay. Now is t is less than critical value, or t is greater than critical value? Is t is less than critical value here. You see that? The test value is less than critical value. So we reject 80. Rejecting 80 means you can say that deer hind leg length is different from the foreleg length. That's what we can decide. Okay, now note, for one tail test we follow the same steps. To find out the critical value, we use the table with one tail, alpha 1, that is for the one tail test, and the decision follows the following. So h1 is population 1 is greater than population 2, then reject 80 if t minus is less than t critical. Okay, and for less than, you do t plus is less than t critical. Okay, this is what you do for the one tail test. Okay, so if you want to do all these steps using R, what you do is, again, as I mentioned, you need that you need this package installed first. Install package and do the run line 86 first and call the library. Okay, and then you need to do, instead of wilcox.test, you need to do wilcox.exact. Okay, so you will be using exact method. So wilcox.exact, and then all other things are same there. Okay, and then if you run this, what you get is, you see that p-value is less than alpha, so we reject the null hypothesis. Okay, and this is exactly same as the one sample test with the difference. For the difference, what I'm doing here is I'm using wilcox.exact, and I'm doing for one sample x minus y, the one sample test for the difference, and mu equals to 0. So alternative is two sides, so everything is same other thing. So you see that you get the same p-value. So again you reject the null hypothesis. Now if you want to do for only one sample, and if you want to do for whether the sample median equals to 147 or not, see these I'm taking the first datum only, and I'm doing the one sample test as I mentioned in the slide. So what you do is wilcox.exact, x is that data, mu equals to 147 is the null hypothesis, and the alternative is that. So if you run this, in that case you see that this is greater than alpha, meaning that the median of the x sample, population of the x sample, is equals to 147. You can say that way. Okay guys, so the true median is equals to the 147 in sample 1. Alright guys, so so what I am going to talk is, so these are the homework problem that you will see in the separate sheet. So the next thing I want to do is the Wilcoxon rank sum test. The previous one was sign test, rank sign test, and this one is the rank sum test. So previous one was used for the paired sample or one sample, and this one is used for the two sample but unpaired one. Okay, so Wilcoxon rank sum test is a non-parametric test equivalent to the Mann-Whitney U test. This test uses ranks of sample data from two independent populations to test the null hypothesis that the sample are from population having equal median. So we will be testing again the same thing. So the population having the equal median versus population do not have the equal median or less than or greater than. Okay, so the idea of this method is, if two samples are drawn from identical population and the individuals' values are all ranked as one combined collection of values, then the high and low ranks should fall evenly between the two samples. Okay, if more low ranks are found in one sample, then there is an indication that the two populations have different median. So we'll be ranking and then see that if both of the samples have equal number of, or the sum of the ranks in the both samples are equal or not. That is the idea. The only assumption in this method has the samples must be independent random samples, and each sample has more than 10 values. So what are the steps on the Wilcoxon rank sum test? Is write H0 and H1 and then combine the two samples as a single sample and then rank them from smallest to largest. This is the same steps that we have been doing in the other test. Find the sum of the rank of either one of the two samples. You find out the rank of those samples and find R. How do you find out R? Sum of the ranks of one of the sample. Okay, so R is the sum of the rank of one of the sample, and in that sample find out mu R, which is n1 times n1 plus n2 plus 1 divided by 2. That is the mu R. And sigma R is n1 times n2 and then parenthesis n1 plus n2 plus 1 over 12 whole square root. That's why you find out mu R and sigma R. Okay, where n1 is the sample size of the sample for which R was calculated, and n2 is the sample size of the other sample. Okay, and find the test value is t equals to R minus mu R over sigma R. Okay, and based on alpha and the tails, find the critical value using normal distribution. So you'll be using the normal distribution to find out the critical value for this method. Okay, and if the test statistic falls in the critical region, okay, if that falls in the critical region, then reject the null hypothesis, otherwise do not reject, or you can use the p-value method. Okay guys, because it is the two-tailed test. Okay, so let us do this example, and I will be doing this all together in R. Okay, so what I'm doing here is, so let me read the question first. So the following data shows the pulse rate of 12 males and 11 females. For alpha equals 0.05, test the claim that males and female have the same median pulse rate. Okay, so these are the pulse rate for the males, these are the pulse rate for the females. So steps. So H0 is the median pulse rate for the male and female are equal versus they are not equal. So two-tailed test, right? Now, first of all, what we do is we mix these two, we combine these two data set. How do I do that? I do C equals to, I just gave a name C, that is combined one. Okay, equals C and then MF. So let me run this. So that is, if you want to know how that C look like, I just type it and run it. See, it is combining the first 12 one is for the first sample, and the second 11 one is for the second sample. Now let us find out what is N1. N1 is how many samples are in M. Male is there are 12 and 11, right? And you need to rank this combination. You need to rank that one too. So let us rank there. Okay, we ranked. Okay, so these are the rank of all these data sets. So the smallest one will be 1, and then 2, 3, and so on. Now, after finding the ranks, you need to add the rank of the males and rank of the females. So which one are the males? The males are 62, 62. There are 12 data set. So on the rank, you need to add the rank of the 12 data set plus the rank of the remaining 11. How did I do that? Rank R1 is the sum of the rank of sum of the R from 1 through 12. This is the R, so you need to add 1 through 12. That's what I'm doing here. So you got R is 123.5. Look at this. So we ranked that way, and then we found N1 equal 12, N2 equals 11, R1 is 123.5. That's what we got. So similarly, what will be R2? I don't think we will need R2 here, but you can find out, just no worries. So R2 is R2 is 152.5. That's what we got here. Okay. Now what is R then? I mean, although we found out R1 and R2, you don't need R2 here. So you can do either R1 only or R2 only. So I'm taking the values from R1. So you pick one sample and find the sum of the rank of that sample only. Okay. So R is that. So I'm taking 123.5. That is the first sample. The sum of the rank in the first sample, I'm taking that as R. Okay guys, so that is the R, and then let us find out what is R. I am taking here is R is 123.5. so find out mu R. Let us find out mu is N1 times N1 plus N2 plus 1. That's the formula we are using here, right? That is the mu R, and that is the sigma R. That's what I'm writing here. That is the mu R, and that is the sigma R. So mu R and sigma R, you will get, let me find out what is mu. So I'm just denoting by mu for the mu R. Okay, So mu is basically 144. Let us compare there whether we get the same. Yeah, mu r, or the mu I denoted here, is 144. And sigma, how about the sigma? Sigma, we got 16.24. That's what the sigma is there. You see that? So that is the sigma, 16.24. Now, what is the test value then? So what does the formula say? For the test value, what do? Is T equals to R minus mu R over sigma 1. Look at that. R1 minus mu over sigma. When you do that T formula, you get T equals negative 1.26. This is the negative value, right? So to find out the P value, what do? You find out the 2 times area left of that, because it lies on the left side. Okay, 2 times the area left of that. How do you do that? 2 times P norm T01, because it is the left area, right? So what do you get for P? P is 0.20, which implies P is greater than alpha, right? So P is greater than alpha. So do not reject 80. So do not reject 80 means what? That means the median pulse rate of male and female are the same. That's what we can say. Okay, so this is how you do by using you do manually in R. But how do you do that directly in R? This is just one line code, line 151. Wilcox.test male comma female, paired is false, because this is not the pair test. Confidence interval and exact is false. If you run that, you get 0.2166. This is the method that you use directly from R, which is close to that value. You see that? So the p-value from by hand and by calculator, directly by R, we got similar. And also the most important thing is the conclusion is the same from either of the method. Okay, guys. So this is how you use Wilcoxon test for paired sample and for unpaired sample. All right. Thank you.